Under the chlorides of elements in period 3, one of the tests we are going to carry out is the dissolving these substances in water, and the procedure is as you have written. The results would be as follows. So this is something that is supposed to be done in the lab session, but we'll first of all look at it theoretically, and you can check on the ones that are going to be available in the lab. Now if you look at the chlorides, the first chloride there is sodium chloride. Is sodium chloride soluble or insoluble? Soluble. So you just write there on that section where you have that space, soluble. Now when you dissolve sodium chloride in water, there is usually a slight drop in temperature, and therefore it means that when sodium and chloride bonds are being broken, then energy is absorbed, and this process is referred to as an endothermic reaction. Okay, so the temperature, what happens to the temperature is that it decreases. Okay, so at that point it's decreasing. What would you expect that the pH of sodium chloride to be? Low. Low means it's an acid. Neutral. So you give the value. What is the value of a neutral pH? 7. Correct. Magnesium chloride. What is your expectation on solubility? Would it be soluble or insoluble? Soluble. For magnesium chloride, when you dissolve it in water, there is an increase in temperature. So that is something you didn't know, but there is an increase in temperature, meaning that when you're breaking the magnesium and chloride bonds, there is release of energy, and this energy heats up the water, which causes the temperature to rise, which is recorded on the thermometer. Therefore, this process is exothermic. This process is exothermic. But when now you heat up the solution, you want to make the crystals, heat of a similar magnitude will be absorbed in the process of crystallization. The pH, what is the expected pH of magnesium chloride? 7. So it's a neutral solution, 7. The other one is aluminium chloride. What do you expect in terms of dissolving in water? Not soluble? Insoluble? Somebody else? Slightly soluble. Now that is guesswork. What you're doing is guesswork there. Okay. So aluminium chloride, you cannot say it is soluble. We say that it undergoes hydrolysis, because it doesn't just dissolve, it reacts now with the water. So solubility, you're going to talk about hydrolysis. It hydrolyzes. It undergoes hydrolysis. That means that aluminium chloride now reacts with the water, which is liquid in state. You end up with formation of aluminium hydroxide and HCl. So you're going to observe films of hydrochloric acid. So in this case, 3 pair, 6 and 6. side. So in that case, you may have something close to that. So you're going to end up with a hydrolysis. The process is hydrolysis. So aluminum chloride undergoes hydrolysis and it breaks down into this one should be this should be 3. This is 3. So in that case, aluminum chloride would just break into aluminum hydroxide, which is a precipitate, and HCl. So you're going to have fumes of hydrogen chloride gas. So because of the production of hydrogen chloride gas, what would you expect the pH to be? The pH of the solution? Acidic is not a pH. It's the nature of the solution. pH should be a value of 2 or 1, okay? Because it's a strong acid. 1 or 2, it will be correct. So it's a strong acid. So pH is 1. Silicon 4 chloride. Silicon 4 chloride. Again also, silicon 4 chloride undergoes hydrolysis. So silicon 4 chloride undergoes hydrolysis. It reacts with the water, and the product is silicon oxide and HCl, gaseous state. So have 4, have 2 there. In this case, silicon 4 chloride reacts with water to form HCl and silicon oxide. Now, before we leave with we get rid of aluminum. Aluminum, by the way, exists also as a dimer. So sometimes you can have it written as A subscript 2 Cl subscript 6 because aluminum chloride exists as a dimer. So that is an important thing to note about aluminum chloride. And this dimer, these two molecules, two aluminum chloride molecules, they interact by coordinate bonds, okay, or dative bonds. So that is also something important for you to note there. If you look at this structure, the structure in your books, where you're having aluminum chloride, the dot and cross structure, showing that we have a complete aluminum chloride. The reaction, or aluminum combines with the chlorine there, that is a covalent bond in between aluminum and chloride. The same applies to the other chlorides. So 3 electrons on aluminum are used for bonding. So we have now a total of 6. The aluminum atom requires 2 electrons. So they are donated by an chloride from the neighboring aluminum kind of molecule, and therefore you have 2 coordinate bonds. So you should be able to draw that under structure and bonding, dot and cross structures. That is important to be able to draw that. So that is what happens with aluminum chloride. Silicon 4 chloride, we say that it undergoes hydrolysis and the temperature increases, basically, meaning that the reaction is exothermic. Phosphorus 3 chloride is also undergoes hydrolysis. Okay, so it undergoes hydrolysis, the temperature increases, and the pH is also going to be 1. So for phosphorus 3 chloride, it reacts with 3 molecules of water to form phosphoric, phosphoric 5, is it phosphoric? Phosphoric 3 acid is, and HCl. So you have two acids being formed, therefore H3PO subscript 3 and HCl. So those are two acids being formed. And for phosphorus 5 chloride, again it undergoes hydrolysis, giving us phosphoric 5 acid and HCl. So again, a lot of heat is generated in this process, and the pH of the resulting solution is 1. Sawa sawa. Are we together? Okay, so those are the behaviors that we note on the chlorides of that is a chloride in period 3 across the period. You're having a substances, first one sodium and sodium chloride and magnesium chloride, being ionic substances that would actually dissolve in water to form neutral solutions. Then we have the other chlorides being molecular. Okay, aluminum chloride is molecular, silicon chloride 4 chloride is molecular, phosphorus 3 chloride is molecular, phosphorus 5 chloride is molecular, and they actually now undergo hydrolysis, all of them, to produce the respective substances, and of course they are acidic in nature, and therefore their pHs are not that it's only sodium chloride that absorbs heat or absorbs energy when it's dissolving. So the rest are substances that generate heat once they dissolve in water. So I think that is the much you can talk about the trend of chlorides across that period.